So in the second part of the lecture, we'll talk about components of user mode. So as we have already seen, in the user mode, we have system support process, we have service process, we have user applications, and we have environmental subsystem and the system DLLs. Now, remember again, from this, what you need to learn that with what functionalities a system support process has, what it can do and what it cannot do. And then some examples. Same for the service process and other components as well. So first of all, system support process manage the system, such as session manager, authentication subsystem, the service manager, and the logon process. So whenever you log into your any online platforms, okay, or in a session, okay, these are controlled by the components of operating system that is known as system support process. So what is a session? So whenever you actually log into any website, that is actually can be called as a session, okay, and whenever you log out, the session ends. And sometimes you will see, suppose you have access to a website, and the website might have a rule like this, that if you are once you log in and if you don't do anything, you will be automatically logged out after 2 minutes or 5 minutes. Okay, so these are the different type of functions that the system support process does. And then we have the service process. Okay, so those are system or application process that actually do run as services. So SQL Server is a very nice example. Okay, and there are some many more. So you can just go through the name, but the basic is that it actually includes system services like task scheduler and the print spooler. So these are actually very important, especially the task scheduler. So it actually defines what tasks will be done when, and if you have multiple tasks, okay, it actually schedules the multiple tasks in a way so that it can be solved in the most efficient way. And we have the user application. Every one of you actually know about millions of applications. Okay, just look at your computer, whatever you see, most of them are user application in the 90% of the cases. Okay, and this include like Microsoft Excel, Adobe Photoshop. 5 application types are supported in the Windows operating system. So we support 5 application types. Now we will not go into the details, but next component is environmental subsystem. Here, as you can see, environmental subsystem. So what the environmental subsystem does, it basically has a dynamic link libraries that work together to allow different application types to function on the system. So when you have different applications, we have seen there are 5 types of applications, and so that they can function properly, okay, and they can share different type of libraries, this environmental subsystem actually dynamic link those DLL files, and they work together to allow different applications types to function on the system. So if you actually just search in your PC right now, you'll find a lot of DLL file. They will actually dynamically link and make your computer using computer much more enjoyable and easy. And then we have this 32-bit Windows operating system, allows 32-bit Windows application to work on a 64. So the one we are talking about. So that means even though you have most of us today, we use a 64-bit Windows. Okay, if you search on your computer, if you type Windows button and R, then there will be a command prompt, and in the command prompt, if you type DXDIAG, okay, so you will actually find what Windows you are using, what edition. So if you are using a 64-bit edition, what will happen, even though the softwares that are 32-bit, you can use them thanks to environmental subsystem. That is the basic and the most important reason that you need to remember. And then we have the subsystem DLL. As you can see from the picture, they actually communicate, service process and user application communicate through subsystem DLL. So as you can see from the name, the DLL means dynamic link libraries, okay, that work together to allow different application types and functions in the system. So the subsystem DLL also does the same. It translates application function calls into internal natives. So basically, whenever you actually want to log into your computer, let's assume that you want to actually connect to the internet. So you have to first log into your computer, okay? And after that, whenever you turn on your computer and you actually just click connect, in the front end, you don't have to do anything else. Your password and username is already given. All you have to do is just click connect. But after clicking the connect, okay, the password verification, the establishing the connection, there are so many small steps, okay, that are being actually done by services. So this service or the system calls are being done by subsystem DLL. So if you go to the task manager of your computer, if you're sitting in front of a computer right now, what you can do, you can go to your task manager, and in the task manager, you can actually, whenever you open the task manager, you will actually see the different services that are going on behind your computer. Even though you are actually just, you think, sir, I'm doing some basic task, I'm listening to you to your class lecture and using a Zoom, so maybe I'm not using any services. No, you are actually using different services. You are using the audio service so that you can listen to my voice. You can using the video service so that you can watch the video. You're using the internet service so that you can actually connect to the internet and actually fetch the data, and so on. The list goes on. So let me show you my task manager. So as you can see in the task manager, if you go, there's an option for service, and if you go there, there are so many services are going on at the same time. Each service has a process ID, PID. So PID means whenever we run a program, it is called process. So this is a process ID, and then we have description, status, and group. So here, let me give you an example. You see WU, this service, this is actually a service that we use for Windows Update. So if you actually don't want to use Windows Update, you can just stop this service. Or if for some reason your Windows Update is not working, you can restart the service. Or you can press go to details, where you can actually edit the part, small part of the service. So what happened, how should I put it? Okay, let's give you another example. So someone's Windows was not taking an update. So they asked me, sir, what's problem I'm facing, that why my Windows is not taking update. And after we saw that the problem was in the WU serve DLL. So there's some part of the DLL file was missing. Maybe it was due to a virus or maybe for other reasons. And the computer was not working. The Windows was not taking update properly. And that's why what we did from the internet, we just shown that how to download, how to check which part of the DLL file is missing. So they downloaded the DLL file, and then they just copy and pasted it to the local DLL file, and then Windows Update was properly working. Another example, that what happened sometimes when the Windows 10 was first released, okay, at the beginning, it used to provide regular updates. Okay, regular updates mean like in the morning there is update, afternoon there is update. And so sometimes what happened, we were actually doing some work online, or maybe we're playing some games, and suddenly out of nowhere Windows started update. Okay, and suddenly that the game started to lag and ping and loss. Okay, so it actually become very annoying. So then we have searched what we can do, and finally we have found a solution that we actually written another process. Okay, that process, so whenever the Windows update tried to start, that process killed Windows Update. So that means the update couldn't start when we were actually using the internet. So these are some examples that you can do using operating system and components of the user mode. Now, I have just given some basic examples, but there are a lot of things you can do. You can actually go through them one by one. Now, next one is the kernel mode. Today we'll discuss the kernel mode, and then the class will be over. I'm talking for a long time. I'm sure you guys are bored as hell. Now, in the kernel mode, as you can see, we have executive, we have kernel, we have hardware abstraction layer, and the device drivers, and also Windows and graphics functions. Now, I will give you a 5 minutes break, and we will resume from 1:36. Now we will talk about the components of kernel mode. As you can see, there we have executive, we have kernel, we have hardware abstraction layer, we have device drivers, and we have windowing and graphics system. So what is an executive? It contains the base operating system services such as memory management, process management, then we have thread management. So we actually don't know that what is a thread, still I haven't discussed, but for now we'll discuss it later. But for now, just to try to focus that this executive contains the base operating system services for memory management, process, thread management, security, input, output, and inter-process communication. What is the inter-process communication? In inter-process communication, what we do, that one process, that is one program communicates with another program. So one program sends data to another program. So that is called inter-process communication. Then we have kernel. Kernel means controls execution of the processors. Okay, the kernel manages thread scheduling, process switching, exception, interrupt handling, multiprocessor synchronization. So we have already discussed what is interrupt handling and what is the exception handling. So sometimes exception handling is like what we use in our code, that if we actually face some undefined or unknown or type of input or cases, what we should do. One simple example that can be that you are trying to connect to the database and for some reason you can't. So that will be an exception handling, that I cannot connect to the internet database. And there are some others as well. For example, another one is, suppose you have written a program that will divide two numbers, and then you have given one number as a 0. So then your program, instead of crashing, if you use exception handling, your program will say that divide any other number that is more than 0. So anyway, so these are some examples. There are more you can see. And then we have this hardware abstraction layer, with what actually does is actually maps between generic hardware commands and response, and those unique to a specified platform. So basically, whenever you're storing data, or whenever you're playing a movie, or you're playing a games, okay, so you're actually extracting data from the computer using computer system bus. Okay, that means we're accessing the computer's memory. Now it can be done using computer system bus. We can do it using direct memory access that we learned in the last lecture, DMA. We can use interrupt controller, system timers, and memory module. So HAL actually makes each computer system bus and other functionalities and other components. So if you combine all of this, the system bus, the direct memory access, DMA controller, interrupt controller, then we have kernel components, executives, they actually make the hardware abstraction layer. And then we have the device driver, the dynamic libraries that actually functionality and the executives. This include hardware device drivers that translates IO functions to specific hardware device request. So basically, if you type, if you want to drag and drop from one folder to another folder, okay, it's very easy for us. We just click the mouse and we just drag and then drop it to another. But in the basic, in the behind, okay, how this function calls, okay, actually translated to specific hardware request, okay, that is being done by device driver. Another example can be Control X. Whenever we want to move a folder from keyboard, we use Control X and then Control V. So we are just using keyboard shortcuts, but behind the screen, these shortcuts are being are translated into commands that the hardware can understand, or I can say the implement. So software components for implementing the file system, network protocols, or any other system extension that need to run in kernel mode, we have the device drivers for that. And finally, windowing and graphics system. We have already talked about so many times about Windows. Implements the graphical user interface, GUI functions, such as dealing with Windows interface controls, drawing. There's a paint program in Windows as well, whether you can draw different pictures. So this is all about kernel mode. So we are actually done with this today's lecture. So we have only one topic that we already know. So identifying Windows interface. So if I ask one of you that what is a Windows interface, most of you will say that it is Windows graphical user interface. Why? Because most of the time users actually spend in the graphical user interface most of the time. But if you are actually a software developer or administrator, okay, you will see that they actually work on command prompt and Windows PowerShell. So if you ask them that instead of Windows graphical user interface, why you are actually using command prompt or PowerShell, they will give you a same answer, that using command prompt and PowerShell is actually much more efficient than graphical user interface. But as a normal user, you might find it actually difficult to comprehend that how can it possible that PowerShell or command prompt is much more efficient than graphical user interface. But whenever you are typing very fast, okay, if you are using a graphical user interface, you have to move your hand from keyboard to mouse. But if you're actually using command prompt or PowerShell, it actually becomes very easy. And there are some other examples as well, but I will not go into the details now. In short, that if you're a normal user, if you do the basic task, okay, in that case, the graphical user interface is much more familiar. or popular. But if you're in administration, okay, working on the back end, in that case, the command prompt or the PowerShell actually helps better. And there is another example that is actually if you are working with like development, okay, graphical development, like if you are working with drawing different designs, animations, okay, in that case, you see there they use another type of interface like graphics tablet. So in graphics tablet, what you can do, you can actually draw in the tablet, and it will see it's almost like you're drawing in the computer screen. So it gives you much more control over the user interface. So these were actually the basic idea, and using this we can actually compare between Windows and other operating system. So the architecture of Windows is very similar to other operating system like Linux and Mac OS, but the key difference is the area of graphics processing. So Windows include graphics capabilities in the kernel mode of the operating system. They can potentially improve graphics performance. Okay, whenever you are doing the graphics course, you will actually have more clearer idea that how actually this is done. But in short, there are some system software and graphics capabilities are embedded into the kernel mode, so that whenever we actually working with graphics, Windows actually enhance the performance. And on the other hand, Linux actually doesn't include graphical function. So Linux actually doesn't use graphical use function. It actually focuses on the core operating system and potentially improve the stability. So basically, whenever you're actually developing your new project, okay, so what happens, we actually, if you remember in C or C++ or any other courses where you actually develop a project, you are actually more focused on the how the code is been working, okay. How it looks, it was not our concern. The same goes for the Windows. So if you are working on in Windows, we actually focus on how it looks, but in Linux we only focus on how it actually performs. And the length of the development does not automatically result in improved stability. So it is also a very important point. So that's the idea. Even though the Unix has been around for more than 30 years and Windows been developed from 1983, okay, it actually doesn't mean much. There are, there are different languages that comes before 2 years or 1 year, and people are using it everywhere. Just think of Python, okay, or C or C++. C has been long for 50 years. Okay, that doesn't mean C is better than Python. Okay, it actually means more about three criteria: what functionalities you provide, your speed, and at the same time whether it's usable by everyone or not. So this is same for Windows. Whenever you are actually using a new Windows, you will actually look for the functionalities on the Windows, or the speed, or how it feels. So all of this combined will actually decide which operating system to use. So thank you everyone.